Hi everyone, Mr. Neighbor, and we're finishing up on gravity. And actually, this video isn't really going to talk much about gravity, but it's going to compare gravitational force to another force in the universe, and that is electric force. So, electrical attraction between two charged particles causes the same type of pull or push between particles as seen when working with gravitation. And we call this formula Coulomb's law. So Coulomb's law, if we really want to, we can denote with F sub E, just like with gravitational force, we would do F sub G because of the electric force. So if we compare the gravitational force, which is capital G times mass 1 times mass 2 divided by our radius squared, it's very, very similar to the electric force. Here we have K, which is the Coulomb's constant, different than the gravitational constant. We have the charge of our particle 1, charge of another particle, and the distance between them. So really the only thing different is this value right here, and that we're talking about charges rather than masses of particles. So when we talk about charge, think about electrons. So how many electrons you have on your head determines how much charge you have on your head if you rubbed a balloon or something like that. And because you might strip away a bunch of electrons from your hair, then they have a positive charge. And that positive charge wants to get away from other positive charges. So then you start to see your hair stand on end because all these positive charges want to get away from each other. And that's because of the electric force. It's a repelling force when two charges are the same type of charge. When they're two different types of charge, a positive charge and a negative charge, then they'll be drawn toward each other. We're going to do just a couple examples with plugging and chugging numbers, but you don't have to understand much of the concept other than the formulas are related right now. We'll do more with electricity later. I do want to point out the constants, though. If you can remember, G was a very, very tiny number. It had an exponent right here that was in the negatives. This is an exponent that's positive. That tells us that this force is a much stronger force than gravity. Electric force is a stronger force than gravity. All right, here we go with some examples. I would go ahead and type this number and store it into the K value because we'll be using it later anyway. So then it makes it a little bit easier when we do these problems. All right, so the force between two identical charges separated by 1 centimeter is equal to 90 newtons. What is the magnitude of the two charges? All right, so let's not look at this stuff right here. I don't know if it's with this problem or not. So let's just plug in what we have. We know we have 90 newtons of force. I know that the value of K is going to be constant, so I'll just have that number there. I'm dealing with two identical charges. That means Q1 is the same as Q2. So I'm just going to have my charge and two of them, so I can simplify that by writing squared. They're separated by 1 centimeter, which is the same as 100th of a meter. Remember, the prefix centi means 100. There's 100 centimeters in a meter. And now I just need to solve for Q. So what I'm going to do is I'm going to multiply these two together. Sorry, I lied. This is in the numerator. This is in the denominator. So I will divide K by 0.01. So that will give me out 8.99 times 10 to the 11th power. At this point, I'll divide this to the left side, so I just have Q2 by itself. That will give me 1.001 times 10 to the negative 10th approximately. And then lastly, I will square root to get Q by itself. So I have an answer of 1 times 10 to the negative 5th coulombs. So C stands for Coulomb, just like this is the Coulomb's law. And the K is the Coulomb's constant. It's a Coulomb. So there you go. Turns out that was not the right answer after all. This could be a positive or negative charge. We don't know. We only know that they are like charges. So they both could be positive charges. They both could be negative charges. All right, let's try this last one. charge Q1 has a magnitude of 3.10 to the negative 6 coulombs. A second charge Q2 has a magnitude of negative 1.5 times 10 to the negative 6 coulombs and is located 0.12 meters from the first charge. Determine the electrostatic force each charge exerts on the other. So we're going to start with our formula. Formula being the electric force is equal to Coulomb's constant times Q1, which is 10 to the negative 6. Multiply that by Q2, which is negative 1.5 times 10 to the negative 6. So these are opposite charges. That means they're going to attract each other. And then I got one there and squared. Nuts. I forgot to square this over here. That was supposed to be squared. I forgot the square. So this is going to have another 2 zeros with it, which means this is going to be 13, which just means this is going to be, this would be then a negative 12 instead of a 10, and then this is a negative 6, so this answer was right. Oops. Okay, anyway, now that we got that cleared up, this is a very straightforward problem where we just have to multiply all this stuff together. And what I get out is negative 2.8 newtons approximately. And when I use sig figs, it would be negative 3 newtons. So a lot stronger force even with smaller things. That's not, well, I would say it is quite a bit of charge. But you would think you would need bigger numbers here, but you don't because the Coulomb's constant is so large. So electric force is a lot stronger than gravitational force is.